Welcome to The Explainer. Today, we are diving deep into the secret language of AI. We're going to break down this incredible white paper that really gets into the nitty-gritty of the tech behind, everything from your Google searches to Chat GPT. So let's get right into it.
It all boils down to this one really fundamental question. We humans, we talk in art, in poetry, in these really complex ideas. But computers, they only speak one language, and that's numbers. So, how do we possibly bridge that massive gap? How can a machine understand the idea of a cat, the fluffiness, the meow, and not just the three-letter CAT?
Well, the answer is this amazing concept called embeddings. And really, the best way to think about them is like a universal translator. They take all the rich, messy, beautiful stuff from our world, text, images, sounds, and they turn it all into a single, unified language of numbers. And that's a language a computer can finally process. And here's the key part, actually understand. And to help us wrap our heads around this, the white paper has this just perfect analogy. Think about it. For centuries, maps were, well, they were a mess, super complicated. But then we had this breakthrough idea to map any spot on Earth to just two simple numbers, latitude and longitude. That one idea changed navigation forever. Well, embeddings are doing that exact same thing, but for everything else, for all of information.
Yeah, this slide really lays it all out. Latitude and longitude tell you London is way closer to Paris than it is to Tokyo, right? Embeddings do the exact same thing, but for concepts. A computer can look at the numbers, these vectors, and see that laptop and computer are practically neighbors, while cars on the other side of the map in this, well, you can call it a mathematical meaning space.
And this quote from the paper, it just hits the nail on the head, because this isn't just about understanding meaning. It's about efficiency. It's about taking something really complex, like a photo with millions of pixels, and boiling it down to a much simpler set of numbers. And that is what lets us search through billions of these things at lightning speed. Honestly, this whole idea of a compact, meaningful number is the very reason large-scale AI can even exist.
Okay, so it's pretty clear these magic numbers are a huge deal. But how are they actually made? I mean, how does a machine learn to look at a word or a picture and spit out a string of numbers that somehow captures its soul, its very essence? Let's take a look at how that process evolved. Man, the journey to get here has been something else. Way back, we started with these super simple bag of words models. They basically just counted how many times a word appeared, completely ignoring context. But then things got interesting. In 2013, we had this leap forward with Word2Vec, which was based on a simple but profound idea. A word is defined by the company it keeps. Fast forward to 2018, and models like BERT could understand the full context of a sentence. And now we have these massive models like Gemini and GPT that create mind-blowingly sophisticated embeddings for pretty much any kind of data you can think of. So this here is a great look at that core idea behind Word2Vec. The model was trained to do one of two things, either guess a word based on its neighbors or guess the neighbors based on a single word. And by doing that over and over and over again, like billions of times, it started to build this amazing map of meaning. It learned that words used in similar situations like king and queen should be plotted really close to each other.
But here's the thing. Today, we're thinking so much bigger than just words. The real holy grail now is what's called a joint embedding space. I mean, just imagine this. A single unified map where a video of a sunset, a photograph of a sunset, and the actual text, a beautiful sunset, all point to the exact same spot. That's the dream, a universal map for all meaning.
All right, so let's pause for a second. We've got this gigantic, incredible map of meaning, right? With maybe billions of points plotted on it. So what's the next big question? Well, how in the world do you find anything in it? How do you search a map like that?
And this is where things get really cool, because this is a massive leap past the kind of search we're all used to. For decades, we've had keyword search. It's totally literal. You type fast car, it finds documents with the words fast car. That's it. But vector search, or semantic search, it's completely different. It searches for the meaning. It finds the coordinates for fast car on our meaning map, and then it finds everything else that's clustered nearby. Things like speedy automobile, racing vehicle, or even pictures of a quick Porsche. You're not searching for words anymore. You're searching for ideas.
Okay, but you can imagine trying to find the closest points among billions of options in the blink of an eye. That's a huge technical challenge.
You can't just check every single point one by one. It would take forever. And that's exactly why we need these special tools called vector databases. They are built for one job and one job only, to run these meaning-based searches at an insane scale and with incredible speed.
So let's recap. We can turn pretty much anything into a meaningful number, and we can search for things based on that meaning. Now, here's where it all comes together. This is not just some clever new way to build a search engine. No way. This is the fundamental engine that's making all of today's generative AI possible.
And a huge part of that is a process called retrieval augmented generation. You'll hear it called RAG. This is really the secret sauce. It's what lets a chatbot, for example, answer a question about something that happened this morning or about a private company document it was never ever trained on. It's how AI gets fresh, relevant info on the fly.
And the process itself is actually pretty elegant. It works like this. First, you ask a question. Right away, your question gets turned into a vector. It gets its own coordinates on the meaning map. Then, using vector search, the system zips through its knowledge base and finds the documents that are closest, the most relevant. That information, that context, is then fed directly to the AI model, which augments what it already knows. And with that fresh info, it can generate a way, way smarter and more accurate answer.
And let me tell you, this RAG process is absolutely essential. By forcing the AI to base its answer on actual retrieved facts, you slash the chances of it just hallucinating or making stuff up. This is what lets an AI use your company's private data securely or tell you about today's news. And because you know exactly which documents it looked at, the AI can even show you its work and cite its sources. It's what takes AI from being just a creative tool to being a reliable one.
So, when you boil it all down, what's the big takeaway here? I like to think of it like this. Embeddings are the alphabet of a powerful new language. And vector search, that's the grammar that lets us read and understand it. Together, they are the foundation that allows AI to think, to find information, and to talk back to us with a level of relevance that's, well, it's just mind-blowing. We're looking at a totally new way of interacting with knowledge, which leaves us with a pretty exciting question to ponder. Now that we can do this, what are we going to find?